Okay, so let's look at our warm-up here. So on the first one, we're plotting these points. So at 1, 1, at 5, 1, and at 2, 5. So it should look like this. Nah, can't do that. Okay, now we're going to translate it using the vector of 4, negative, or negative 4, negative 6. So what is negative 4, negative 6 going to do? Left 4, down 6. Okay? So every point's going to go left 4, down 6. So we're going to go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Up 4 over 1, so it should be like this. So again, that point goes to that point, that point goes to that one, and then that point moved from there to there. Okay. Down the next one, negative 1, 4 is right here, negative 5, 3 is right here, and negative 3, negative 7 is right there. Okay, and then what is the vector 8, 3 going to do? What's that vector 8, 3 going to do? Right 8, up 3.
So then negative 5, negative 3 be down one more?
Oh, whoops. Yep. Shoot. That's going to jack that all up. Yeah, like that. Okay, so they're all going to go 8 right. 1, 2, 3, 4, 5, 6, 7, 8. Up 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 5, 6, 7, 8. 1, 2, 3. So it should look something like that. All right, so today we're going to talk about reflections. Okay. Okay. So on reflections, and okay. So this word is isometry. Isometry. I-S-O-M-E-T-R-Y. There's going to be like a question on your test on this, where it asks you what an isometry is. So definitely make sure you get this down. We'll be talking about it. So an isometry is a transformation that does not change the size or the shape of the figure. Okay? So it's whenever you move it in some way and it stays the same shape, stays the same size. And so yesterday in translations, a translation is an isometry because it doesn't change the shape or size. And in reflections today, it's an isometry because it does not change the shape or size of the figure. Okay, so a reflection is a transformation that moves a figure by flipping it across a line. The reflected figure is called the image. Okay, so on this one right here, does this look like a reflection? No. What does this look like?
Translation.
That's like we did yesterday. This is a translation. It just slid straight over. So no, that's not a reflection. That's an example of a translation. Does this look like a reflection? Yes, it does. Okay. And if you think about this line right down the middle here, that's what it got flipped over. That's what we call the line of reflection. Okay? That line right there is the line of reflection. Okay, so what I want you to do is, and only do this on the first one because I'm going to change it on the next ones, but go ahead and plot those 3 points, X, Y, and Z on that grid. There's the origin right there. Plot those 3 points, X, Y, and Z on this grid. Okay, so what we're going to do is we're going to reflect this thing across, and it tells us right here, the x-axis. So which one is the x-axis? The horizontal one right here. Okay, so we're going to flip it across that line right there. All right, so here's how I do it. Is all I'm going to do is count how far each point is away from that line of reflection. So for point X, how far is X away from that line of reflection?
1.
It's 1. And since it's 1 below, I'm doing a reflection. I'm going to flip it along the same line 1 above. So X is here, 1 below. X prime is going to be 1 above right there. Okay? So that right there is X prime. All right, now let's count how far Z is from that line. So Z is down here, so it's 1, 2, 3, 4, 5, 6. Okay, so it's 6 below. I'm going to flip it 6 above. So along that same line, I'm going to go up 1, 2, 3, 4, 5, 6, and right there. 1, 2, 3, 4, 5, 6. And then how far is Y below that line of reflection? 3. It's 3 below. To do the reflection, I'm going to flip it 3 above. So along that same line, 1, 2, 3. There is my Y prime. And then there you go. So you can see if you were to fold it along the x-axis, that red line there, if you were to fold your paper along that line, that those two images would match exactly up. How this point and this point would match up, this point and this point would match up, and then this point and this point would match up. So what are the coordinates of x prime? 2, 1. What are the coordinates of y prime? Is negative 4, 3. And what's the coordinates of z prime? Is it 3, 6. Okay, so I want you to follow me on this because I don't like these points.
Good afternoon, PHS. This announcement is for juniors for our movie incentive. Teachers, please check your email for those students who are not to attend and who are to attend class as normal. All other juniors will be dismissed at this time. Head to the auditorium, please. Thank you.
For juniors. Okay. So, all right, here's 0, 0. It's kind of hard to tell, but right where the x and y meet. Okay, let's go ahead and plot a point at, I'm just totally forget about these. I don't like where those are at. So we're going to put a point at 2, negative 2. We're going to put a point at 2, negative 5. And let's put a point at 4 or negative 1, 2, 3, 4, 3. Okay, so like that. Now on this one, we are reflecting it across the line x equals 2. So where is the line x equals 2? Okay, so it is this line right here. Well, it's parallel to the y-axis. But it's going through the x value of 2 right here. Okay, this line right here is the line x equals 2. That is the line x equals 2. So make sure you shade that in on your paper. Shade it in on your paper. Need people listening, please. See a lot of people with blank papers. Shade that in on your paper. X equals 2.
Yes, sir.
Okay, so this is the line x equals 2. So what I'm going to do is I'm going to count how far this point is away from that line. So how far is this point away? 1, 2, 3, 4. So since this point is 4 to the left, I'm going to go 4 to the right. And that's where my new point is going to go. So 1, 2, 3, 4. There's the reflection of that one. Okay, for this point right here, it's 4 away here, so I'm going to go 4 this way over here. And then this one right here is 6 away, so I'm going to go 6 this direction to right here. And there's my reflected triangle. Okay. Next one. Okay, I'm going to put different points on here again. I don't like those. Those just not working. Okay, so let's put a point at 2, 2, at 1, 2, 3, 4, or 1, 2, 3, 4, 5, 1, 2, 3, 5, 3, and then at 2, 7. So 2, 2, 5, 3, and 2, 7. Thank you, ma'am. Okay, on this one, we are reflecting over the y-axis. So the y-axis is this one right here. Bless you. So how far away is this point?
2.
It's 2. So I'm going to go 2 the other way. So right here. This one up here is 3 away. So 1, 2, 3 there. And then this one is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Like that. Okay, on this next one, same thing. I don't want to plot these, but I want to write down the coordinates of these new ones. Okay, so let's plot one at -4, -1. Let's plot one at, let's see, 5, 7. And then one at -1, 6. So plot those 3 points. -4, -1, 5, 7, and -1, 6. Okay, now in this one, we're going to reflect over the line y equals x. So where's the line y equals x? Okay, so the line y equals x, where's that tool at? I can't remember. Oh, well, I'm just going to do it like this. Okay, so the line y equals x is like this. It's like the diagonal line that goes through here like this. So draw that on your paper. Okay, to do a reflection across the line y equals x, all you do, there's a little rule here, is you switch the x and y value. Okay, you switch the x and y. So like back up here to this one, this -4, -1. So if you just switch those, it's going to become -1, -4. Okay, I'm just flipping them. The 5, 7 is going to become what? 7, 5, and then the -1, 6 is going to become what? 6, -1. So let's plot those new points, and you'll see how those are exact flip across that line that we drew there. So -1, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, -1. All right, so on your assignment, I want to see you drawing them like this. Let's see those lines drawn on there to show me where you're reflecting across.